Hello. In the previous classes of inverse trigonometric functions, we have seen sine function and the sine inverse function. Okay. Now today we are going to take up the inverse cosine function. Inverse cosine function. So before coming to inverse cosine, we have to do cosine function. We should study about cosine function. Study about means why we have to study this. In what intervals cosine function is bijective? Have you heard of the word bijective? That means 1 to 1 and onto function. 1 to 1 and onto function. That is called a bijective function. Whether cosecant x, the cos x, cos function is cosine function is bijective at what intervals? So for that we will draw the graph. We will be immediately able to fix the intervals where cosine function behaves as bijective function. Now here y is equal to cos x. X belongs to real and y is equal to y belongs to closed interval -1, 1. So that is the domain of cos function is any real number. But at this real number domain, the cos function does not behave as 1 to 1 and onto function. So we have to restrict the domain. That we know from the cos function graph. Zero, pi by 2, 5, 3 pi by 2, 2 pi, and minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. So follow how I am doing this graph of cosine function, cos function. Now here we should mark 1 and -1 because the range or the values of cos function is from -1 to 1. The value of the cos function is from -1 to 1. So in this interval only the graph of cosine function will be there. So first when cos 0 is there, it is 1, its value is 1. Cos pi by 2 is 0. Cos pi is -1. Cos 3 pi by 2 is again 0. Cos 2 pi is 1. So this is the positive side of x-axis. Now the negative side of x-axis, the curve is cos of -pi by 2, cos of -5, cos of -3 pi by 2 and cos of 2 pi. Now where this cosine function behaves as 1 to 1 and onto function. Yesterday I have told you how to decide 1 to 1 function. When you draw a horizontal line, the line cuts the graph only at one point. So that happens in this interval 0 to pi interval. You can see 1. Only when you draw a horizontal line, only one point. Suppose in this 0 to pi, if you minus pi by 2 to pi by 2, if you put, you will get 2 points. That is many to one function. Now in this interval, that is 0 to pi, cos function behaves as 1 to 1 and onto function or bijective function. Like this, other intervals also, cos function pi to 2 pi, cos function will remain as bijective, and minus pi to 0, minus pi to 0, and minus 2 pi to minus pi. All these intervals, cosine function will remain as So Let me mark this for you. This is the principal value branch of cos function. Principal value branch of cos function. Y is equal to cos x graph. Y is equal to cos x, and this branch is called the principal value branch. Okay, so what is principal value? It is the least, numerically least value. Numerically least value is called principal value. For example, 0 to pi. Suppose if you take pi to 2 pi, what happens? It is not the least value. 0 to pi is the least value here. You can also ask, sir, minus pi to 0 is also least value. Yes, but we are taking only the positive values. Numerically, least value means positive values, not negative values. Okay, so we are taking 0 to pi interval. Cosine function behaves as 1 to 1 and on to. Okay, bijective. So it can be inverse. That is, we can get the inverse function. Now I will draw the graph of inverse cos function. That is, inverse cosine function. Y is equal to cos inverse of x. So x belongs to minus 1 to 1 and y belongs to 0 to pi. Y belongs to 0 to pi. Here also, first I started with the real number, but we have made this as 0 to pi. So whenever we have inverse functions, the domain and the codomain interchanges. Capital X, if it is domain, that will become codomain for inverse function. So that is what is happening here. This is the codomain y. Now let me draw the graph of inverse cosine function. Now here, what is the value of x for cosine function? Cos inverse of x domain is minus 1 to 1, and this is the origin. Okay, now here let us mark pi by 2, pi 2, 3 pi by 2 and 2 pi. Okay, so in the below we will have minus pi by 2 below the x-axis, minus pi by 2, minus pi. So for all the graphs that I am going to draw, the same method we are going to follow. Minus 3 pi by 2 to 2 pi. That is minus 2 pi to 2 pi. We are taking the graph. Okay. Now cos 0 is cos inverse of 0 is 1. So where it starts, you see, and then it goes like this, and here, and again it comes like this, and it will reach 2 pi. So like that here. So which part is this one? See, cos inverse, a beautiful thing is coming from the graph. That is, it is always, its value is always positive. Its value is cos inverse of x never becomes negative because it is 0 to pi. Okay, it is positive only. From the graph also you will perfectly be able to understand from the graph. Now you can draw this. This is the principal value branch of cos inverse of x. Principal value branch of cos inverse of x. Principal value branch of cos inverse of x. So this graph is y is equal to cos inverse of x, and this is principal value branch. Principal value branch of cos inverse of x. Principal value branch. Now, yesterday we have seen sin x and sin inverse of x. Now you have to write the notes for that. I will start writing the notes, what we have done so far, what we have discussed so far, that we are going to write it as a notes here. The domain of cos function is the set of real numbers. The domain of cos function is a set of real numbers. Already it is there. And what is the range of cos function? And the range of cos function is closed interval minus 1 comma 1. Closed interval minus 1 comma 1 is the range. Now, in this domain, cosine function does not behave as inverse function. So, what we are going to do is, we are going to restrict the domain of cosine function. So, if we restrict the domain, to square bracket 0 comma 5, then cos function is bijective, and cos function is bijective, and the range is minus 1 comma 1. The cosine function is bijective in the intervals minus 5 comma 0 square bracket 0 comma 5 and 5 comma 2 pi. You can see the graph. Minus 5 to 0, this branch 0 to pi and pi to 2 pi. In these intervals, the cosine function is always bijective, etc. Okay, the cosine function with the range as square bracket minus 1 comma 1. Square bracket minus 1 comma 1. So what we have done is just we have converted cosine function into bijective function. 1 to 1 and onto function. Now, once we have a cosine function which is 1 to 1 and onto or bijective, then we can have inverse cosine function. Okay? Now I will write the inverse cosine function notes for you. I will write it. Now we will write the notes for inverse cosine function. The inverse cosine function denoted as cos inverse cosine function denoted as cos inverse. Yesterday previous classes we have done sine inverse. There I had given you the inverse functions are also have another name. What is that name? In bracket arc cosine. Arc cosine means cos inverse. Arc cosine. So inverse function denoted by can be defined as with the domain as square bracket minus 1 comma interval and the range as 0 to pi. The range as 0 to pi. Okay. Now this is this one. But in the intervals minus pi to 0, 0 to pi, square bracket pi to 2 pi, we get a branch of inverse cosine function. A branch of inverse cosine function. So, in IIT examination and all, they will ask for this interval, they will give for cosine inverse function and then put a problem there. You have to use pi to 2 pi interval and find out the values. So, that is why these intervals are taken. Not only in 0 to pi is called principal value branch. The branch with range as 0 to pi is called the principal value branch. Principal value branch or cos inverse. Now this is over. Again I will read it. Inverse cosine function denoted as cos inverse or cosine can be defined with the domain as square bracket minus 1 comma 1 and the range as 0 to pi. So in the intervals minus pi to 0, 0 to pi, pi to 2 pi, we get a branch of the inverse cosine function. The branch with range 0 to pi, square bracket 0 to pi is called the principal value branch. Now we define cosine function. Cos inverse is from, see, domain is minus 1 to 1 square bracket. The range is 0 to pi. See, whenever the range is the codomain set, then it is onto function. Range is the codomain set, then it is onto function. So range of cos inverse is 0 to pi, so it becomes onto 1 to 1 and onto. So this cos inverse function is also a bijective function. If inverse function is bijective, if a function is bijective, its inverse is also bijective. That is from the definitions of inverse functions. Okay. Next we will go to cosecant x function. Cosecant function. Now we are going to see inverse cosecant function. Inverse cosecant function. Okay. The last we will take tan x and cot x. But we should know now the domain of cosecant x. First we have to draw the graph of cosecant x. Here in the previous classes I have mentioned what is the domain of cosecant function. So here x belongs to r minus n pi, n belongs to integer, and y belongs to r minus 1 to 1. So this is the range and the domain. Domain is r minus n pi. Why r minus n pi? We have to remove all integral multiples of pi. At integral multiples of pi, the cosecant x is infinity. Therefore, it is not in the set of numbers. So that we have to remove. Now we will draw and find out which are the principal value branches or where the cosecant x behaves as 1-to-1 and on-to function. Now let me draw the cosecant x function x o x dash pi by 2 pi 3 pi by 2 2 pi minus pi by 2 minus pi minus 3 pi by 2 minus 2 pi. Okay, now let us see. Cosecant x does not exist for integral multiples of pi. I have put a dotted line there. All of you should know how I am drawing the graph of cosecant x. And you see, cosecant of minus pi is also infinity. And the cosecant of integral multiples of pi, 2 pi minus 2 pi. So here I have done cosecant x graph I am going to do. Now what is the range of cosecant x? So here you mark 1 and minus 1. See, cosecant x range is greater than 1 here, greater than 1, less than minus 1. So in between minus 1 and 1 there is no part of cosecant x. No part of cosecant x exists between minus 1 and 1. So how I am going to draw? You see, cosecant x, cosecant 0 is infinity. So from infinity it will come to 1. Cosecant pi by 2 is 1. And then again when cosecant pi is there, it again goes to infinity. So first quadrant and second quadrant, cosecant x is positive. First quadrant and second quadrant. Now we will draw cosecant of 3 pi by 2 is minus 1. So the graph comes from minus infinity to minus 1 and then again it goes to minus infinity. That is third quadrant and fourth quadrant. Third quadrant is 5 to 3 pi by 2 and fourth quadrant is 3 pi by 2 to 2 pi. Both cosecant x is negative. Cosecant x is negative. Now here cosecant of minus pi by 2, that is also minus 1. Cosecant of minus pi by 2. And here cosecant of minus 3 pi by 2 is plus 1. So you can see the graph of cosecant x. Here, what is the principal value branch? So cosecant x here minus pi by 2 to, can see minus pi by 2 to. So this part minus pi by 2 to plus pi by 2. Minus pi by 2 to plus pi by 2. We can have cosecant x. Now I will draw this. So here, even this is not required. Here there will be no part of the graph will be there. It is not required here. This is not required. Like that. Here also we don't need. So this is the part, the region. So this is our principal value. So cosecant x behaves as 1-to-1 and on-to function in the interval minus pi by 2 comma pi by 2 square bracket. But in this we have to remove 0. 0 is in between minus pi by 2 and pi by 2. What is cosecant 0? Cosecant 0 is infinity. So we have to remove this. So this is the value, that is the range for, that is the domain for cosecant x. Domain for cosecant x is this. And the range is r minus 1 comma 1. And you can write this as y is equal to cosecant x. And This is called the principal value. Principal value branch. Principal value branch. You understand how we have to? The first year also we have drawn this graph. Now also we are doing it cosecant x. Now we will go to cosecant inverse of x. Y is equal to cosecant inverse of x. Y is equal to cosecant inverse of x. X belongs to, what is x? R minus 1. Y belongs to minus pi by 2 to pi by 2 minus set 0. Okay. Here, what are the other intervals where cosecant x behaves as 1 to 1 and on to function? Very simple. You see, pi by 2 to minus pi by 2 minus set pi. And here, minus 3 pi by 2 to minus pi by 2 minus set minus pi. In these intervals also, cosecant x behaves as 1 to 1 and on to function. Now we have to draw cosecant inverse of x function. Cosecant inverse of x. So, what is the x value? R minus 1 minus 1. So, mark 1 and minus 1 and do a dotted line. So, in this part, there is no cosecant inverse of x graph. There is no graph here. Minus 1 to 1. No, sorry. This will be, we have to interchange x axis and y axis. X axis and y axis. So, we have to mark 1 and minus 1 here. 1, minus 1 and 1. Okay. Carefully watch how we are doing this. So, in this interval, there is no part of the cosecant x cannot be, x value cannot be between minus 1 and 1. Okay. Now we have to take minus pi by 2, pi by 2, pi, 3 pi by 2 and 2 pi. Minus pi by 2, minus 5, minus 3 pi by 2, minus 2 pi. So here, in these values also, minus pi, 0 and pi, you put a dotted line. Now, cosecant inverse of 1 is pi by 2. So, the graph becomes like this. In the first and the second quadrant, it is positive value will be there. And here, you get negative value. And 2 pi also, you should go mark it like this. Here minus 2 pi also, put the marks or dotted lines. Now you will get, here there is one branch. And here you see what is the branch? You see minus pi by 2, minus 1 is minus pi by 2. And here it will be positive and it will be like this. The principal value branch, that is very simple. You make it here. This value, this branch, that is minus pi by 2 to okay. Minus 1, minus pi by 2. Minus pi by 2 to pi by 2, minus pi by 2 to pi by 2. But 0 should be excluded. 0 should be excluded because there is no value of cosecant inverse of 0, that is infinity. Cosecant inverse of 0 becomes infinity. Cosecant inverse of minus 1 becomes minus pi by 2. Cosecant inverse of 1 becomes pi by 2. So this is the value. So this branch is called principal value branch. This value is called a principal value branch, and this is called y is equal to cosecant inverse of x graph. Cosecant inverse of x graph. Okay. Again, you can see this. Whenever you draw minus 1 and 1, you should take. Then pi by 2 pi, and here what is the x-axis? Minus 1 and 1. Y-axis it is there. Now it will come to x-axis. We are interchanging x and y-axis. Then we will be able to draw the inverse function. Now we will take the notes. Since cosecant x is equal to 1 by sin x, cosecant x is 1 by sin x, the domain of cosecant x, the domain of cosecant x is cosine function. The domain of cosine function is the set square bracket, cover bracket x belongs to R, x not equal to n phi, x not equal to n phi, and n belong to z, and the range is y belong to R. Y is greater than 1, y is less than or equal to 1. Y belong to R. Y is greater than or equal to 1, y is less than or equal to minus 1. That is R minus bracket minus 1 comma 1. R minus bracket minus 1 comma 1. That is the value for the range value. So it means cosine function, cosine function is not defined. Cosine function is not defined for integral multiples of pi. Integral multiples of pi. It means cosine function is not defined for integral multiples of pi. Okay. And assumes all values x hat y greater than minus 1, less than 1. These values cosecant x cannot take. All the other real number values cosecant x can take. So that is the meaning of this domain and range. If we restrict the domain to square bracket minus pi by 2 comma pi by 2 minus set 0, square bracket minus pi by 2 comma pi by 2 minus set 0, then it is 1 to 1 and on 2 with the range as R minus bracket minus 1 comma 1. So we are converting the cosine function into 1 to 1 and on to function in the interval square bracket minus pi by 2 comma pi by 2 minus set 0. So in other intervals also cosecant function will behave as 1 to 1 and on to functions. What are the other intervals? Cosine function restricted to square bracket minus 3 pi by 2 comma minus pi by 2 minus set minus pi comma square bracket minus pi by 2 comma pi by 2 minus set 0 and comma square bracket pi by 2 to 3 pi by 2 minus set pi etc. It is bijective and its range is ordinary bracket or minus bracket minus 1 comma 1. So we have defined cosecant function as 1 to 1 function in the interval square bracket minus pi by 2 comma pi by 2 minus set 0. So in other intervals also cosecant x behave as cosine function behaves as 1 to 1 non-2 function. Those intervals are square bracket minus 3 pi by 2 comma minus pi by 2 minus set minus pi and minus pi by 2 comma pi by 2 square bracket minus set 0 and square bracket pi by 2 comma 3 pi by 2 minus set pi. So in these intervals also cosecant x is bijective. So it can be, we can get inverse cosecant function. Okay, next paragraph. Thus, cosecant inverse can be defined. The cosecant inverse function, now inverse cosine function we are defining, can be defined as a function What is the domain now? The domain, whose domain is R minus bracket minus 1 comma 1, and the range could be any of the intervals square bracket minus 3 pi by 2 comma minus pi by 2 minus set minus pi comma square bracket minus pi by 2 comma pi by 2 minus set 0 square bracket pi by 2 comma 3 pi by 2 square bracket pi by 2 comma 3 pi by 2 minus set pi and so on. Okay. the function corresponding to the range square bracket minus pi by 2 comma pi by 2 minus set 0 is called the principal principal value branch of cosecant inverse. So we define cosecant inverse as cosecant inverse is from minus or cosecant inverse is from r minus 1 comma 1 to the range is minus pi by 2 comma pi by 2 minus set 0. So you can write domain and codomain for the cosecant inverse function.